Hello students, today we are going to discuss the properties of alkyne. You know, alkyne mainly contains triple bond, that is 2 pi bonds and 1 sigma bond. You see the reactivity of alkyne and see triple bond generally stronger than double bond and single bond. Bond strength of triple bond is stronger than double bond than single bond. This is the rate that bond dissociation enthalpy of triple bond, double bond, single. But if you see the chemical properties of alkyne, the properties of alkyne are almost similar with alkene because it has pi bonds. But number of pi bonds of alkyne is that is greater than the number of pi bonds present in alkene. It has 2 pi bonds, but in alkene it has 1 pi bond. That's why the number of addition reaction is more in case of alkyne, and it also shows same common properties, that is electrophilic addition reaction. Electrophilic addition reaction like alkene because it has pi bond. So what are the different electrophilic addition reaction? We'll discuss. This is one. First is with hydrogen. If added with hydrogen in presence of catalyst, that is nickel catalyst, and on heating produce ethane. But here it has been observed that if the acetylene is this type of compound, addition with hydrogen on heating in presence of palladium, barium sulfate and sulfur. This is called Lindlar catalyst. Already we have discussed in Alkyne chapter. This is Lindlar catalyst. It gives generally Lindlar catalyst gives cis alkane, CH3 H CH3 cis H. This is your Lindlar catalyst. Formation of this is cis alkane. Cis, you will get cis. And if same compound with sodium and liquid ammonia, and this is called breach reduction. Breach reductions, and the result is trans. This is trans. Okay. So remember this two. Same acetylene can be converted to alkene, that is controlled reductions, and this barium sulfate acts as poison which will stop the further reduction alkene to alkane. So you have to remember this. So this is addition. In both cases, this is the addition of hydrogen. Then addition of halogen also you can do it. Halogen, if you add, the product will be tetrahalogen derivative will be obtained. Tetrahalogen derivative obtained, and the reactivity will be fluorine, chlorine, bromine, iodine. This is the reactivity of halogen. Then with the halogen acid, the product will be, first will be CH2 and double bond CHX, and further reductions another XX, result is CH3, CHX and X. This is Markovitch, following the Markovitch law. Already we have read that addition when the alkene is unsymmetrical, then alkene is unsymmetrical, then the negative part attached to the carbon having less number of hydrogen. That's why it is follow Markovnikov rule. Here the reactivity is Hi greater than HBr greater than HCl greater than HF. Because this is the bond dissociation enthalpy in case of Hi is low. That's why it is more reactive. So this is addition with the hydrogen, addition with the halogen, addition with the halogen, then addition with the halogen acid, hypohalous acid, HOX. First result is CH2 double bonds, CH, that is CHX, then CHOH. Then further reduction HOX, similarly CHX2, then single bond CHOH and OH, and this is unstable. This is unstable because two hydroxy group cannot be attached to CH group because unstable due to repulsion. So loses water molecule forming CHX, then X, CHO. That is dihalogen derivative of aldehyde will form. Aldehyde ketone form depends upon the structure. If it is unsymmetrical, let it be CH triple bond CH. Similarly, two molecule of HOX, the result will be CH3, C here OH, again OH, then CHX and X. So this is following the Markovnikov rule. Following Markovnikov rule, the result will be loss of water molecule from this produce ketone. So the product, this is ketone derivative. This is ketone derivative is formed. So the product obtained depends upon the structure of alkyne. If the alkyne is long chain alkyne, then always the OH group attached to the carbon having less number of hydrogen. Because in HOX, this is minus, this is plus. So negative OH group attached to the carbon having less number of hydrogen. Thus, as it has two molecule added in the same carbon OH. So result will be loss of water molecule, result will be ketone. So when OH group will be added at the other than terminal carbon, the result will be ketone. If it is added at the terminal carbon, result is aldehyde. So remember, this is very important difference between that formation of aldehyde and ketone derivative. It depends upon the structure of alkyne. So this is addition of halogen acid with water also, CH triple bond CH. But we know acetylene do not react with water, but in presence of reacts with water, in presence of sulfuric acid and mercury sulfate, if you take, then the result will be same CH3 here. Two times it will added HOH, result will be CH and OH, it loses water molecule, and the result is CH3 CHO, aldehyde. It is aldehyde. But if it is other than acetylene, same water molecule, here two molecules of water added, same reagent is same. Here result, middle carbon takes OH group. As per the Markovnikov rule, it will follow because it is unsymmetrical. It will follow Markovnikov rule. The result will be loss of water molecule. So it is ketone. That is acetone, name is acetone. But we know this is very important. Difference is when water will added to alkyne, it gives aldehyde or ketone. When hypohalous acid added to alkyne, it produces also aldehyde or ketone derivative. So this is very important difference between addition reaction of alkene with water having different carbon atoms. Then these are some important addition reaction of alkyne. Then if you see the oxidation reaction of alkyne, you see alkyne undergo oxidation with ozone. It also like your alkene, it gives two steps, and second step is the addition of zinc and water hydrolysis. The product is CH, single bond CH, double bond O, double bond O. Here O and O will be added, but here one bond will remain. In case of triple bond, one bond remains. In case of double bond, there will be no bond. It will be separated. So, and then this is the glycol. Glycol is produced. But if it is your triple bond, that larger group, same do zinc and water, the result will be CH3, C double bond O, CH double bond O. This is aldehyde and ketone. Both aldehyde and ketone group will be there, because the result will be just addition of oxygen. Everything is same, addition of oxygen, only triple bond becomes single bond. So remember, this is very important difference between addition reaction of ozone with triple bond, or that is oxidation of alkyne. And this is one type of oxidation. Second oxidation, if you use that bromine water, if you use bromine water, it will also produce addition of bromine. Then bromine water reddish brown color become colorless. This is one important test of also alkyne. And this alkyne also oxidized by KMnO4. Oxidation by alkaline KMnO4 and finally produce oxalic acids. Addition also. Similarly, if you take triple bond having more number of carbon atoms, oxidation cell using this part will be oxidized, it produce acetic acid, then remaining formic acid. But on further oxidation, it also gives carbon dioxide, and it also gives carbon dioxide. So you have to remember this oxidation of KMnO4, oxidation of alkyne by KMnO4, by bromine water, by ozone. This is the oxidation reaction of alkyne. So what are the acidic properties of alkyne? Let us discuss acidic properties. Acidic nature of alkyne. You see acidic nature of alkyne. You know, acetylene mainly contains carbon which has sp hybridization. If sp hybridization, so S character is 50%. S character is 50% S character. As it has 50% S character, so electronegativity of this carbon is more compared to alkene. You see, CH triple bond CH is more, this carbon is more electronegative than double bond, than single bond. This is the electronegativity. If electronegativity is more, then acidic character of this CH bond is more. Acidic character, if you compare, CH triple bond CH is more acidic than double bond, is more acidic than single bond, because 50% S character, here 30, that is 33%, here 25%, because sp hybridization, sp2 hybridization, and this is sp3 hybridization. So s character is decreasing. If s character is decreasing, the electronegativity of carbon for the bonded electron increases. That's why H can be released as H plus. So more S character, more acidic CH bond. CH bond will be more acidic if CH bond attached to carbon-carbon triple bond. If carbon-carbon triple bond, carbon attached to that hydrogen attached to carbon-carbon triple bond will be acidic character, because this carbon has more S character. That's why acetylene is more acidic than ethane. We have to remember that this is the difference between acidic character of alkyne, alkene and alkyne. Let us discuss some acidic character of alkyne. While it is more acidic, so it reacts with sodium metals. Triple bond acetylene having acidic hydrogen reacts with sodium metal, produce salt. Salt is CH triple bond CN, monosodium acetylides, and it can be converted to disodium again. NaC triple bond CN, that is called sodium acetylides. Acetylide salt, sodium salt will be formed. If it reacts with same acetylene, reacts with filling solution, some salt solution or Tollens reagent. Tollens reagent, that is silver nitrate and ammonium hydroxide. This is called Tollens reagent. It reacts with Tollens reagent, produce Ag triple bond CAG, silver acetylides. This is white precipitate is formed as white precipitate. Here what happens? Silver, as it has acidic hydrogen, so this Tollens reagent produce salt with acetylene because acidic. So from this salt is water insoluble and obtained as white precipitate. Similarly, this is same CH in presence of filling solution, FeH, filling solution is copper sulfate and ammonium hydroxide. It also produces copper salt. And these copper acetylides, formation of copper acetylide, this is red PPT. Red PPT is formed with filling solution. This is and with Tollens reagent produce silver salt. This is copper salt, and this indicates this CH bond having hydrogen. This hydrogen is acidic character and produce salt. This is important properties, acidic properties of which one? Alkyne. Okay. Isomerization reaction also takes place. Isomerization of alkene, for example, CH3C, when it reacts with sodamide and inert solvent, it produces CH3C H, then CH3CH2, then C triple bond CH. So this is 2-butyne, this is 1-butyne. So formation of 2-butyne to 1-butyne using sodamide. This is called isomerization, 2 to 1, 2-butyne, 1-butyne. And polymerization, reaction, acetylene, 3-mole acetylene when heated in presence of iron tube and and red hot produce benzene. This is polymerization. If you take propyne, do same, you will get this is benzene, this is 1,3,5-trimethyl benzene. These are polymerization reactions. This is called also mesitylene. It is also called mesitylene, Me, mesitylene, or 1,3,5, 1, 2, 3, 4, 5, 6, 1,3,5 trimethyl benzene. These are the polymerization reaction of alkyne, that is acetylene derivatives. So these are very important reactions of alkyne. Mainly the reactivity of alkyne depends upon the hydrogen attached to carbon-carbon triple bond. This, suppose this is, it do not react with sodium metal, no reaction. Why it does not react with sodium metal? Because it has no acidic hydrogen. Because it has no acidic hydrogen. No acidic hydrogen attached to C111C. That's why butyl, this is which butane? 2-butane. 2-butane is not acidic, but 1-butane acidic. It is acidic because it has acidic hydrogen. This carbon has no acidic hydrogen, but this carbon has acidic hydrogen. That's why you have to see the nature of alkyne. Okay, you practice. These are very important reactions of alkyne. Okay, thank you all.